In the third part of the experiment, you are now going to determine the ethanoic acid content of this vinegar sample by carrying out a titration with the sodium hydroxide solution, which you now know the concentration of very accurately. So the first thing we're asked to do is take 25 cubic centimetres of our vinegar solution into a prior washed out pipette, transfer it into a 250 cubic centimetre volumetric flask and make it up to the mark. So we're going to be doing our analysis on a diluted sample of our vinegar. We then transfer 25 cubic centimetres of our diluted vinegar sample into a conical flask. We'll add a few drops of indicator, and then we're ready to start doing our titrations with our previously standardised sodium hydroxide solution. So we'll do a rough titration and then as many titrations as necessary to achieve concordancy. So here are some made up results for my titration of white vinegar against the sodium hydroxide solution. So let's say my rough titration gave me a titer of 16.2. My first accurate titration was 16.3. Although those two are within 0.1, they cannot be counted as concordancy because you never use your rough one for concordancy. So let's say I was really good and my second titration was also 16.3. So those two are concordant, give me an average volume of sodium hydroxide of 16.3 cubic centimetres. So now I have to calculate the concentration of ethanoic acid in the diluted sample of white vinegar. So the number of moles of sodium hydroxide required, C times V. The concentration as determined in the previous experiment was 0.127 moles per litre. The volume was 0.0163, giving me 2.07 times 10 to the minus 3 moles. Now, from the balanced equation, you can see that the ethanoic acid and the sodium hydroxide react in a 1-to-1 ratio. So the number of moles of ethanoic acid is going to be the same. So the concentration of the ethanoic acid will be number of moles divided by the volume. So number of moles is 2.07 times 10 to minus 3 divided by the volume, which was 25 cubic centimetres. So 0.025, which gives a concentration of 0.0828 moles per litre. Finally, we have to calculate the concentration of ethanoic acid in the white vinegar, not the diluted sample. So, if you remember, we started with a vinegar bottle, and from that we made a diluted sample, which is the one that we titrated. We took 25 cubic centimetres of the vinegar and diluted it to 250 cubic centimetres. So a 10 times dilution, going from 25 to 250. So what we've just calculated here was the concentration of dilute vinegar, which was 0.0828. So the concentration of the vinegar must have been 10 times greater than that, 0.828 moles per litre. And when that was diluted by a factor of 10, it gave that concentration. So this is our answer. concentration of ethanoic acid in our white vinegar was 0.828 moles per litre, according to these rather made up results. So, you've now worked out the concentration of ethanoic acid in the vinegar sample. But to give you an idea of whether or not your method worked, you're now using the exact same technique going to analyse the ethanoic acid content of a control sample. That is one of accurately known concentration already. So we know that this bottle contains a solution of 1 mole per litre ethanoic acid. So you're going to see if the technique that you've just used gives you that value for this control sample.